Hello everyone, welcome to our next video on Introduction to Functions. Welcome to this session. In this session, we will explore one of the most fundamental concepts in programming, that's called functions. We will understand how functions works, how to define and use them, and the role of Python standard library. We have divided coverage on this topic in two parts. Post covering the theoretical and conceptual aspect of functions, we will run through several examples as per your syllabus in a Jupyter notebook. So in follow-up video, we'll be taking several hands-on example where you can take a problem and try and code it. Let us get started on this topic. We have divided this in 4 or 5 major areas. In this session, we'll cover the basis of functions, delve into user-defined functions, discuss variable scope, and look at Python's rich standard library. By the end, you'll be able to write modular and reusable code with use. What is a function? A function is essentially a block of code designed to perform a specific task. By using function, you can make our code modular and reusable, saving time and effort in programming. Python provides built-in functions. Some of these you might have already seen, say print or input or length, and then you can create your own user-defined functions. As you might see, if you have to write a utility to find out the cost based on certain parameter for a tent that you can see on this side with a cylindrical base and a cone at the top, if you write calculators for a specific part of this tent, then you can put relevant code used for calculating price or area of a specific part of this tent in one go, and that will help you debug it further, that will help you reuse it if need be. With this in mind, let us move on to the next slide. Here, as you might see, we defined a function using keyword, that is DEF or define. So the first 3 characters for defining a function are reserved characters, DEF, followed by a unique name and optional parameters and the function body. So your function might have 0 or more parameters. It is expected to have some function body, and eventually at the end of the function you might have an implicit or explicit return statement. If you have an explicit return statement at the end of the execution, that particular execution is returned to the caller. If you don't have, then the last line that is getting executed, that will be returned to the caller. So you might see this, a small example of grid, right? So def, define, grid, that is a function name is the parameter, and then you end that with a semicolon, and then your body is with a tab or whatever you have set in your editor indentation. So here you are just having simply return hello and then concatenated with the name that you passed. And if you see, to call it, you can actually give a either you can explicitly assign to that name, or you can just have the value. So here we are simply having value a student, that will be assigned to name, and once the function body will be executed, we return hello student. So in key components, function name, parameters, return, and this define a specific keyword to define the function df. As you can see on the upper right part, where we have function header and function body, everything that is under a square bracket, you can assume that those are sort of optional. It means that your function might not receive any parameter and it might not have an explicit return statement. With this in mind, we will expand upon user-defined functions. So user-defined functions allow you to create custom operations tailored to your program needs. In this example, we have defined a function to calculate the area of a rectangle, right? So define calculate area, length and width, and as you know, the formula for calculate area is length multiplied by width for a rectangle, and you can call it, can put it inside a print to see the results. In this particular case, 5 into 315 will be printed. User-defined functions with default variables. This is an important topic even from your exam perspective. You need to understand couple of underlying variation to correctly answer many of your MCQ type of questions around UDF and default variables. Default parameters allow a function to have predefined values, making it more versatile. So in this particular case, if you see the previous example where we wrote an UDF to calculate area, if you are sure that width is always going to be 10 or default value of width is going to be 10. This might be the reason that wherever this function is being used, one of the common width parameter could be 10. When the function is called with only one argument, it will use the default value of width. However, a second argument is passed, it overrides the default value, demonstrating how default parameters enhance function usability as well as avoid certain kind of cumbersome common values that users have to repeatedly call with. So as you might have seen in this particular case, when you are not passing in the first call, if you are only passing 5, so that is linked to the parameters in order from left to right. So length is assigned 5, and since you don't have a value for width, width will be taken as default one, and 5 into 10, 50, that will be the output. So we'll spend few more minutes just to ensure that you are following the right part of the slide. So we are talking about this part of the execution, right? So since you have only one parameter, that is 5, the second one about width is taken as by default. That's why you will see, if you execute this in a notebook, you will see the output 50. When you will actually provide an overridden value for this, now no more width will be taken as the default value. Your length will be the first parameter 5, and your width will be 20, and so your answer will be 100. One thing that you can keep in mind, that when you are defining default parameters, they need to be in order. So you cannot have default parameter first followed by, so for example, you can't have calculate area with length is equal to 10 and width not assigned any default value. That will result into one of the error appropriate for this. Once we get into Jupyter Notebook, we'll see you the error stack trace for that. Hopefully you have got a good idea about UDF with default parameters values. Now in functions, it might so in the inside the body of the function, right, there are two scenarios possible. A variable scope determines where it can be accessed in a program. Global variable exists throughout the program, while local variable exists only within the function where they are defined. So in this particular case, if you see, if you have defined x is equal to 10, so again let me illustrate it. So this is the global variable x is equal to 10, right? Inside the display, you have defined a local variable which x is equal to 5. In this particular case, usage of x within this will be as per local. So x is equal to 5 is what? The overridden value, and that will be used. Once we go to the you know a notebook, we'll see that if you want to access the the global one in this inside the function, you have to use with explicit resolution operators like the one that we have just drawn here, right? Okay, again you might be tested several variation of these definitions in your exam. Now let's talk about Python standard library. Python standard library is a treasure trove of built-in models and functions that make programming faster and easier. For instance, the math module provides mathematical functions like a square root, and the random module allows us to generate random numbers. There are several commonly used Python standard libraries, and in the appendix below, we will see several uses of it. Some of the common functions that you might be using, say math.square root, random.randinit, and whenever you are using a particular built-in library, you have to use with this import, right? So for example, import math, right? And if you want to you know uh, if you want to export only a specific packages from there, you can say from math import file, right? That kind of things. So this brings us to the common coverage uh, on the conceptual part of functions that we wanted to cover. We'll summarize what we have covered so far, and then we'll look at some of the built-in function libraries and how they can be used. Key takeaways: functions, as you might have already seen, they help you organize your overall code in a way that makes programming efficient and modular. Python provides both built-in and user-defined functions alongside a robust standard library for quick development. You must make yourself comfortable and leverage those tools in your program. So you can see some of these built-in functions. These are taken from your textbook. So the one around input or output are input and print. We just saw input in our previous you know uh, session, right, where we can actually ask user to input value. We are using printing for quite some time. On data side conversion, right? On data side conversion, uh, we are having all these different uh, bool, character, dictionary, float, int, list, set, string, and tuple. On the mathematical one, we have the one to find out absolute value, uh, into the max, min, power, sum, and more utility functions that you will use on your day-to-day task. They are length, range, and type. I think we extensively use range in several of our previous video, particularly when we are discussing loopings. We'll see extensive use of length going forward, and type also we have seen it, right? So if you provide type and provide an object inside it, uh, Python will help uh, infer the object type for you. You can, in this table you can see, for example, this is from math, right? So you can use import uh, you know absolute or ABS from math, and then you can start using absolute value of x, right? As you know, what is absolute value of x? It will be either for an integer or for a floating point. It will be positive part of the answer. So if it is negative, it will be actually negated again, and absolute value of, say, for example, 4 will be 4, but for minus 4 it will also be 4. When we are looking for this particular uh, diff mode, right, here both x and y are integers, and if you look at what it returns is the quotient and remainder. So if you are looking for 7 modulo 2, it will return your quotient, that was 3, and remainder, that was 1. With 7.5 and 2, what it will return? It will return 3 and 1.5, right, that way. Max of a sequence, it will return the max number out that. You can pass anything. In the first example, we are passing a list. In the second example, we are passing a string. So it will actually give you the character with max value. And then ceiling and floor, right? So ceiling will give you uh, the next bigger number. So on negative side, it will be lower. For example, minus 9 is greater than minus 9.7, while positive 9.7, the next number will be 10. So anything above 0.5 will be taken plus one more for positive and one less for negative number. Floor is opposite of it, it will take you the next lower integer. So 4.5, anything less than 0.5, it will actually taken on the lower side. So 4.5 will become 4, 4.6 will become 5, again 4, right? Yeah. Then you can take, absolute value of it, which again gives you the positive part of the answer. Factorial, you have simply factorial, multiplication of all the numbers. You can give an integer and you can get all the multiplication of that as an answer. The similar way you have GCD, power, square root, and as well as sine, cos, theta, those kind of trigonometry related. Random is something, you should spend sometimes. You can do import random, right? And then you can use random.random for real numbers. By default, you'll get, some number between 0 and 1. Rand in it within two range. So it will actually can give any integer number between two numbers. 3 to 7, minus 3 to 5, right? Minus 5 to minus 3. Including both the list, right? And random.rand range, this will actually give you a random integer between 0 and y, right? So if you're looking for rand range, it will give you some number between 0 and y. And when you are looking for rand range x and y, so then in this particular case, you'll get between x and y. The one that you should make yourself comfortable should be random.random and random.rand in it. This will be needed in several scenarios. And then the third most important used for you will be statistics. You can do import statistics, and then you can use mean, median, mode, and many others. Some of these are tested in an exam also. So, statistics.mode for 1124, 1145. We are looking at the last example, right? So 11. Red, blue, red, right? And in a similar way, mean and median. Okay, so with this we come to end of this module functions. We'll have a follow-up session using some of the hands-on coding example. See you guys in next video. If you are liking and it's helping you in some way, please like and subscribe.